Hey everybody, this is Larry. This is me doing week 2 of the Leetcode weekly challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, 280 Wiggle Sword. So basically, let's take a look at what I paid for. Okay, so giving it away, we ordered such that num sub 1 is less than, greater than, less than, and so forth. There may be any, there may be a lot of answers, right? So, okay. Let's see. I mean, I think there are a couple of ways you can think about it. I think if you actually do a wiggle, it's gonna be tough to kind of get it all right. I think the idea behind these kind of ad hoc problems is just try to figure out another way in which order invariant holds, right? And I think for me, it's just sorting, right? Meaning that if num sub 0 is the smallest number and num sub 1 is the biggest number, then this will always be true. And if this is the second smallest and so forth. I think the only thing that I might worry a little bit about is like at the end or something like that if I'm not careful. But and maybe we could play around with that, right? Like if we have three numbers, we could start with, we have three numbers, 1, 2, 3, and we just do 1, 3, 2. That should be good. What if we add a second, another number, right? Then will be 1, 4, 2, 3, which is still good, right? Like, the smallest number, and then kind of wiggle back. And then let's say we do a 5, right? What would that look like? 1, 2, 3, 4, 5, right? Is that still good? Looks okay. I mean, obviously, this is not quite the same as a proof, and should not be confused with a proof. How do I? So 4, 5, 6, right? So then 6, 5, and 4. I mean, but this is good enough for me to have the confidence to at least do it, right? So okay, so we sort the number and yeah, do it in O of n time complexity. Can I do it in O of n time complexity? So yeah, I mean, this is going to be right? And then we finagle it back and then re-indexing it. Actually, we did a problem yesterday on shuffle sorting, so it's kind of like that one. So I think we're okay here. But I mean, it may be tricky to actually get it right, or like getting 100%, with the edge cases and stuff like that. But the algorithm is going to be right. Now let's see if I can figure out how to do an O of n time complexity. That one I'm not super sure about, to be honest. I mean, at least without some linear linear sorting, like based off this 10 to the 4th number, which I don't think that's kind of within the spirit of O of n in this case. If that's the case, then it'll be very sad, or at least like I'll be sad. I mean, I think you can actually do the same thing, but median finding. Now that I think about it, right? If you're able to find a median in O of n time, which I mean, roughly expected, you can. I mean, you could also just randomize it and you could get the median, right? And if you could get the median in O of n time, then it's the same idea, really, right? Because there's no that we're talking about, because basically you have half the numbers that are bigger and half that are smaller going backwards, and order half. I think that's it, though. I think that is going to be the idea and the solution. I do wonder if there's a Python like get median algorithm, because I am lazy. But apparently there's a statistics library. Is that a thing? I mean, we could always implement the median finding, but it's not as interesting to me to kind of do it, to be frank. Let's see if this works. I just googled it, so because this would be new to me at least, so we'll see. So at least I'm learning something as well. No, I guess you don't return anything for this one anyway. I was just going to return a placeholder. Okay. 3.5. Okay. I mean, so then now I mean, it's very annoying to kind of do this um, within like all of one extra space, and I'm not sure that you can anyway because median finding. No, I mean, I guess median finding is all of one. Oh, sorry. Well, I mean, it'll be O of log n or something, right? Space. No, I mean, oh, sorry. You could do it of O of one, just do it in place, period, right? Same thing with like quick sort or something. Okay, yeah. So I guess you could do it of O of one space, but I am not going to spend that much time on it, I think, because mostly I'm lazy. Uh, well, assuming that this one does it in O of one because you can do it in place, and then because you're supposed to modify it anyway. And then now that you have the median, then you want to uh, uh, I mean, there's a lot of just like cases with the finagling. I don't think I want to do it, to be frank, meaning that it's actually not impossible, but it's just really annoying, um, because it's just like almost like because you can use something like similar to what is that country, Dutch flag or something. So you could do something like that, the Dutch flag algorithm or something like this, and kind of it's not quite, and then like put them into place and then do some. I'm not gonna do all that. I'm not gonna lie. I'm a little bit lazy. So let's just do something like this, and then left or like smaller is equal to num sub or x for x in nums if x is less than or less than median, say, right? And then it's larger or equal to, but and it doesn't really matter which way you go. And then basically, it is just answer. Right. Hmm. Can I just take half? Oh yeah, I guess in this case I can just take. I don't even need to do the interleaving thing, right? Because basically the original idea was that I can do some sneaky thing, right? Meaning like 1, 2, 3, and then 4, 5, 6, like some snake. But because it doesn't really matter what the order is, so then it can also just be 4, 5, 6. And also if the larger array is way bigger, because mostly because it has the same number, then all of them can go at the same time because it's not a strict thing. It's a equal thing, less than in this kind of wiggle. So it should be okay. So that basically, now that we pivot it, so we can actually maybe change this to I wouldn't call it sorted, but pivoted is equal to this plus this, right? Say. So now we have a pivoted thing, and then now we can do this thing that we were saying with the perfect shuffle that we had yesterday. In one of the things, I forget which one. This is like, without context, this is going to be like a ridiculous looking code. Or like, it's like, why did Larry make these decisions? But everyone, you don't try this at home, I suppose. Oops. Was it num sub I, obviously, and then num sub I plus n over 2, something like that. I wonder if I have to double check that. I forgot it's not an answer thing, but I mean that's fine. Yeah, I mean we'll make it back, but actually I don't even need this then, right? Then I just do. Oh, I actually did this wrong anyway. I need to period it, and then num sub I is times 2 is equal to this, and then I think I have to also be careful about odd numbers, which is not in the input, something like that, right? Let me just run it real quick. Should be right, but now we have to. I don't think this is right with an odd array though, because I mean it may be right by accident, but I definitely just like ignore the last number. So basically, yeah, if n mod 2 is equal to 0, then num sub I guess last number is equal to pivoted last number, I think. Is that not right? Oh, the number in the middle would be the last number out. No, is that true? Huh. The last number in nums. Oh. I mean, this is true. It's just that I am dumb and I put. Oh well, okay. I mean that was wrong anyway, but but this is still wrong. The idea I think is mostly right, but so what did I output? 3, 2, 1. So the median is 4, I think. Wait, is it? Let's print it out real quick. Maybe I just had a mistake on. Maybe it may be that my assumption is not right for even numbers or odd numbers. Sorry. Okay, so I have this, and then the pivot, I guess, is either 4 or 5, and then you have this thing. So then now you're matching. Oh, I see. My original assumption was that it doesn't really matter as you throw out the big stuff and the small stuff. That's kind of what I was saying. But I think that I was assuming that all these numbers were the same. But because they're not, and because now we have an extra one, we have to. That's annoying to handle. Because we have an extra number, we have to figure out where to put it. Okay. And the extra number in this case is a 5, but. If this was sorted, it's okay. But I guess for this period. Because and you can kind of you could even draw it out with an even answer, I think, maybe depending on how it gets matched up. Okay, maybe not, but I'm it's just like part of the oddity that for thing, but I mean I think one thing that we. So the last number. Because the hard part is having an extra number, right? Because basically the idea is that if you have 1, 2, 3, and then now you have 2 and 3, but then because the way that we separate them, we have 1 and then 2 and then 3, but then we just add 1 and then 2, and then we add the last number, which is 3. This is wrong. Actually, yeah, this is already a case where this is wrong. But how do I do it without sorting? Yeah, see? Okay. I guess we can just put the median numbers at the end. I think maybe then that would be okay. But I don't know that this fixes it, to be honest. I mean, this fixed this one, but the idea is that yeah, now this is too weird maybe, because it goes 5 and then matches to 6, and then now you have this thing where, wait, what? Oh, because now this is way too long. Let me think about this. It's just really weird because we have to handle median in a weird way. Or rather, maybe we just pivot it this way. I don't know. It just brings so much edge cases to it, and this is like doing it the cheating way. Like you can imagine that if we did it in place and kind of implemented the thing, it would be wrong. Yeah, that's why I didn't do it this way before. I don't know. How do we handle the case where? So this is basically having an issue where there are a lot of. Is there? So because this is basically causing an issue if and only if median is if there's an odd number and there's a median. What do you do with the median number? You just put it in the end. I thought that you could just put in the end, but I guess I'm wrong on this one. Wow, I didn't expect this particular part to be that tricky, to be honest. But okay, maybe we can just separate it out instead of kind of complicated this all at once. And then here we can keep it as the way that we were, because if it's even number, I think we're fine either way. Or like the old way was fine, but then now if it's odd, then we want to treat the median differently. We don't want to. We want to make it the first element, maybe even, right? No, it doesn't really matter, because there could be odd number of median numbers. Huh? Didn't really think about it. To be honest, I don't. No. I mean, even if you sorting it would have been okay. Yeah. How do you do it with the median? Don't know. And I'm getting hungry. Now he is getting hungry. If, because the thing is, that means that we assume the median is a small number. We just put in the back. Which is okay, I think. Maybe? I don't know. I don't know if that's true, to be honest. But let's try that real quick. And then now you do. I don't know that I'm convinced that this is right, but the idea is that I'm forcing at least one of the median numbers at the tails, because then it will always be the median. In this case would be always be large, or like if you want to write it out, right? Like I'm just gonna write out, you know, small, large, and then some median number, right? And then the idea about having it in the median is that we're basically interleaving it, and then median will be smaller than the large number no matter what. But I don't know that I'm convinced. But let's give it a submit. Oh no, I knew that a case like this was going to be my bane. But okay, so this odd number and the median is 1, so then actually, yeah, now I put all of that afterwards, so this is even really wrong, because now it's putting 2 1 1 1 1. So because it's putting the median numbers, yeah. I mean, I could also do it another sillier way, but I don't know. Yeah, okay. Let's just do it a dumber way. I think I tried to be too clever with this. But basically, or like I tried to be too clever with this part, to be honest. I think we can just do it in a more straightforward, silly way. Basically, what we had before, which is this is equal to this. But we have it on a queue, right? And then basically, right? Something like that. Oh, maybe same. Right? And then basically, yeah. For I in range of n, num sub I is equal to, or maybe something like while I is less than n is equal to smaller pop left, and then the next one will be larger dot pop left. Right, and this is if smaller, if length of smaller is greater than 0, right? If length of larger is greater than 0. What happened to, oh, I don't even know anymore. Oh, there should be, I don't know if this is true anymore. I'm just getting way confused. But yeah, yeah, else sub I is equal to maths.pop left. Something like that, but I don't know. This is so hard without the sorting. Something like that, maybe. Oh, whoops. Right, let's give it a try. I mean, I'm happy that I kind of grind through it, but this is kind of much trickier than expected, and obviously very linear space. I mean, you could kind of do the math in the same way without all the decks by just keeping track of a lot of indexes, and that probably would still be constant space if you, or constant extra space because we're taking advantage of nums. But that's just like really ridiculous for me anyway. I'm really tired, friends. Let me know what you think. This is linear time, linear space. Yeah, assuming that this is linear and these three things are linear, and of course you're just going through the array one at a time, so it should be okay. Cool. I'm really tired, friends. So yeah, I'm gonna call it a night. So stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.